Welcome, Eric. Eric is a member of the Conda-forge core team and has been involved since its beginnings at SciPy 2015. Professionally, he's currently at Vaultron Data, product managing their enterprise offering. Previously, he has held a variety of roles, including Director of Data Science Platform at DTN, Principal Solutions Architect at Anaconda, Computational Engineer in EdTech at MaxPoint, and Assistant Scientist and Postdoc at Brookhaven National Lab. He holds a PhD in chemistry, though was not a particularly good chemist, and is much better suited to tech. And Eric is going to give us an update on Conda-forge in 2021.
Thank you, Florian. Let me share my screen. Please feel free to interrupt at any time. I will keep an eye on chat and Q&A and kind of, address them as they come up. Cool. So we've got Conda-forge is a pretty enormous team here. We pulled the GitHub avatars for, some of the main teams here. We have a reasonably large core team. There's 25 of us kind of here on the right of the slide. We've also got what's called an emeritus core team. That's up here in the top left. Those are folks that have been active at one point, but have chosen to step away for, a variety of reasons. There's a large team that manages our staged recipes. And if all of these words are not making any sense, just give it about 3 to 4 slides and things will start to make sense. We've got a staged recipes team. That's these 12 folks here. And then there's a whole lot of other people that are maintaining the recipes that make the Conda packages that we all use on a day-to-day basis. Our core team is involved in a very broad variety of communities. We've got a couple folks from BioConda, the current Conda lead over at Anaconda. There's a guy at CERN. Not to read off the whole slides here, but there's folks that are contributing to Arrow and Parquet. We've got the Mamba primary author, Jupyter Hub folks here, AstroPy. It's a pretty broad ranging community that has hooks into a lot of places. Quick outline, going to cover just kind of what is Conda, what's the UX today, go over some fun numbers, and then go over the architecture and some of the design constraints of Conda-forge, and then how to get involved at the end. There will be lots of time for questions now and throughout. Okay, so quickly, what is Conda? It's a cross-platform package manager, meaning that you can install packages on most all common hardware that exists today. There was a question earlier in our public Gitter channel, does it work in Docker? And the answer is yes. It works anywhere that you can run Conda, basically, which is Docker on your local machine, cloud, HPC. I think it would work in embedded. I know it works on Raspberry Pi. It's been around for a little over 10 years, created back in 2011 by Anaconda to solve the scientific packaging problem. It was becoming extremely hard to install things like NumPy and SciPy with the built-in Python package, or with the set of tools approach. So Anaconda went to the core team of Python, basically said, hey, can we work with you to solve this scientific packaging problem? They said, no, go and solve it yourself. So they did. And that's where Conda came from. And I should note that Anaconda in 2011 was called Continuum Analytics. It's way broader than just Python. We've got support for all of the languages listed on the third bullet. I will note that if you're familiar with GPU accelerated computing, it's how NVIDIA, or it's how the Rapids team does all of their package management, that and Docker. And Conda obviates the need for compilers on the user system because it puts that load on the package authors. So you only have to compile it once instead of every user having to have all of the compilers to install your packages or to install your code from source. Quick getting started. These are all active links. There's a lot of links scattered throughout here. The docs are fairly robust in terms of all of this. On the left, if you're familiar with, using Python from Anaconda, you may be familiar with some of the syntax here. So creating a Conda environment, to do it from Conda-forge, you just need to add the Conda-forge channel. That's this yellow bit here. If you use the mini Conda images from Anaconda, we've got similar ones from the Conda-forge organization on Docker. We do not manage anything like the Anaconda distribution. That is an extreme amount of work on the Anaconda side. We do not have the staff, nor really the charter, to go and solve that kind of a problem. But there are many, many teams and companies that build their own internal distributions from the Conda-forge packages that are available. If you use the mini Conda installer, we have similar installers called MiniForge and Mamba-forge. Those are available basically in the outer product of these 4 columns here. So they're available in both an install script and a Docker image with Conda and Mamba for a couple flavors of Python on a wide variety of platforms. You can get the mini Conda, or you can get the MiniForge and Mamba-forge releases from the link in the top right, and the Docker images also from the link in the top right. Again, this link here will take you through a much more verbose version of what's the contributor user experience. This slide is mostly just to kind of walk you through if you're not familiar. I'm already 10 minutes in, and the vanity metrics are way more fun. Does it work with Alpine? I will take that as a note and get back to you on Slack. There's so many questions like this. I'm not, I don't want to speak incorrectly, so I will get back to you on that. If you're on Twitter, give me your Twitter handle and I'll @ you from the official Conda-forge account. The question was, does Conda-forge work with Alpine? Yeah, so again, this is a lot of text on here. There's a couple of things to point out. We are available on Gitter. Gitter is a live chat service that's free, I think it predates Slack, or came into vogue about the same time that Slack was gaining its popularity. So if you need live chat and just you want to ask a live question that isn't really a good place for a GitHub issue, please feel free to use either of the links here. When you release a new version, we've got a bot that automatically goes and tries to find, or that goes and grabs that version and updates your Conda recipe and the feedstock. Again, I'm not going to go through this slide in great detail. The fun part is the vanity metrics, which I wanted to spend some time on. We have over 3,300 individuals that have committed to maintain packages. They have admin on one or more repositories in the Conda-forge ecosystem. There's 25 of us that have kind of admin rights over the whole org. We're almost up to 16,000 libraries that can be installed via Conda. Our bot has issued over 100,000 PRs. I think 105 of those have actually been merged. In terms of individual artifacts, these 15,000 libraries turn into 708,000 total packages, 3.6 terabytes of storage for all of those packages. Oh, I should have done total traffic. I'll have to add that for the next time I give this talk in 2022. We're a little over 5 billion downloads since Anaconda started keeping track of our daily downloads. That was in March 2017. Would maybe add a little bit if they had kept track since the inception in 2015, but it's a pretty small tail. At that point, we are almost at 300 million monthly downloads as of last month, less than a million away. And for most of this year, we've had more downloads than the Anaconda channel. Now, it's possible that's because Anaconda did change their terms of service to try and drive some business value for them. And so, either way, it's still a lot of traffic. And we support 6 platforms, as listed in the second to last bullet. Charts wise, so the top is the download count for Conda-forge and Anaconda in green and yellow. The bottom chart is for the smaller channels. I'm gonna pause here for just a second and take a sip of water. Okay. Conda-forge works via free CI services that folks have donated in kind. This is the number of builds per day that we're doing on our various CI systems. Azure Pipelines is by a very wide margin the most heavily trafficked. Microsoft very generously donated 200 parallel builds for Conda-forge. We do a lot on GitHub Actions as well. Conda-forge was created initially using Travis CI for Mac builds, Circle for Linux, and AppFair for Windows. And so we still use those a little bit, but not to the extent that we did at one point. The number of packages over time since February, I think, of 2018 has been growing fairly consistently month over month. And then the total size here. There's a lot of different components of Conda-forge. If you've ever submitted a pull request to add a new library, you've interacted with the Stage Recipes team, or with the Stage Recipes repository on Conda-forge. From Stage Recipes, what's called a feedstock is created. That is a Git repository that the recipe maintainers have full admin on. CI services are hooked up to those feedstocks via our automation. And packages are built on the CI services and pushed up to a staging channel. And then we have a web service that then goes and validates that the artifacts are what they're supposed to, and then promotes them to the main channel. We have a whole separate bot organization that does stuff like it's got the automated management of the feedstocks down, so you can ask it to update your feedstock for the latest version of Python. You can ask it to add the Mac builds for the new Mac chips. It handles monitoring for new builds. All right, I see a new question coming in. I will. All right, etc. Adam, when that question comes in, I will pause and read it off and then answer it. Conda-forge, we don't own any infrastructure, so we don't own any hardware that does any builds, other than individual dev laptops that we sometimes need for very specific long builds like Qt. There's nobody who's paid that's to work on Conda-forge. If there's if you want to get involved, just start doing stuff. We'll probably add you to the various teams. We love it when folks get involved, because it means that we can now cover other things, or that there's no use cases that we can go and solve for. We don't have any recurring revenue, so there's no sales team. There's no products that folks buy. There have been a few donations over the years. Individuals are supporting Conda-forge, but there's no money coming in. We managed to bootstrap the whole thing on, I think we've spent less than $10,000 ever all time. So there's a question in the chat. Give a quick overview of Conda-forge as it compares to other package managers. Why is Conda-forge special? Conda-forge and Conda are, so Conda-forge is one source for Conda packages. Conda is the package manager. The most package managers are either language specific or platform specific. So, you know, apt and yum, et cetera, on Linux. You've got things like homebrew and Mac ports on Mac. You've got the Windows one. Chocolatey, I think, is the Windows one. And then, you know, there's pip and wheels, but pip is very Python specific. So Conda-forge is really one of the only, you know, cross-platform things that gives you the same commands on Linux and Windows and OS X and all of the other platforms that we talked about. I should go to the next slide while I talk about this. Did that answer your question, Adam? And if not, perhaps a follow-up, and I will address that in a minute. There are 4 major goals that we have in Conda-forge as listed in the left of this slide. You know, we want to be as transparent as possible. It's just kind of a core design goal that we have. When there's no secrecy, when there's no like this build got created on someone's laptop and we're not sure of its provenance. I guess what I'm trying to say here is the transparency builds trust. And Conda-forge only works as the central place for community Conda package management when there's trust. We have, you know, a couple of aspirational goals. It'd be great if every possible package that exists on Conda-forge can be installed with every other package. Obviously, that's an infeasible task to achieve in reality. But I would say that Conda-forge has a, you know, eventually compatible model. Over time, packages will usually end up working together because somebody will hit an issue and then go and figure out why and fix it. We have another aspirational goal of, you know, we would like to be able to coexist with Anaconda. There have been times in the past, like, you know, 2019-ish and earlier, when it was almost a guaranteed failure if you were installing from the Anaconda channels and from the Conda-forge channels. That is, we went through a pretty Herculean effort to standardize compilers and tool chains across Anaconda and Conda-forge to reduce that burden. This only works via a heavy dose of automation. And so there's, you know, lots of automation here. And then the core team of Conda-forge doesn't really own anything. I mean, we have admin on 16,000 Git repositories, but the Conda-forge ecosystem heavily relies on the, you know, over 3,000 individuals that are maintaining the Conda recipes and creating builds as new versions of their libraries are made. Let's see. Last slide. If you want to get involved, here's a little, you know, if you like the thing on the left, go check out the thing on the right. You know, if you want to grow the capabilities of what you can install with Conda, start getting involved in the staged recipes team. That's, you know, github.com/conda-forge/staged recipes. I'll just put that in chat. Right. Staged recipes. If you really like maintenance and keeping things running, you know, there's a list of under-maintained feedstocks. That's where Conda packages come from. You know, just hop in our Gitter channels and start answering questions or asking questions. Read through the docs and make things clearer when they're not clear. If you really like automation, we have a bot team that is also like-minded and super obsessed with automation. There are links on this slide for how to get involved there. And if you want to financially support Conda-forge, there's a couple of paths there. There's, you know, donations through nub focus, and there's donations of, servers and hardware and stuff. Servers is a little challenging. We're working with Quantsite to get some GPU servers so that we can actually do GPU enabled builds. But that is it for now. Thank you all for listening. And with that, I will have, there we go. Can you talk to some of the efforts around the Mamba project, Bo, et cetera? Yeah. So, well, hold on. That's a good question. I'm going to go to the next one first. Also about Conda-forge. What's the best / easiest way to set up a company internal mirror of Conda-forge to save us from traffic? So I would say set up your own mirror if you want to own your availability. Traffic is generously paid for by Anaconda. That they spend a lot of time, sending packages to a globally distributed CDN. I guess that's a redundant statement, but whatever. So, another set of thanks to Anaconda there. There's a library that I wrote called Conda Mirror. I will add that as well, github.com/conda-incubator/Conda Mirror. That basically does that for you, or it's the way that you can get packages from anaconda.org to inside of your firewall. Beware of that. If you're a company, do not mirror the Anaconda channels. There's a terms of service on there. I would also highly encourage you to look at their paid offering, just simply because, having maintained an internal mirror, and I know exactly what you're signing yourself up for. I think their pricing is fairly reasonable. So if I would definitely get in touch with Anaconda. I believe it's called Anaconda Team Edition. Okay, Jason. So talk to some of the efforts around Mamba, Bo, et cetera. Yeah. So the Quant Stack team led by Sylvain Corley, they are a team of really, really good C++ devs. They wrote like the Zeus project, which is writing C++ in like Jupyter, like kernels, which is a very strange thing that I've never really wrapped my head around fully. But anyways, the Conda solver ended up getting progressively slower as the number of packages that were available that you needed to account for to solve an environment grew. And eventually the Conda solver just wasn't able to keep up. And, sometimes we would encounter solve times of, 10 minutes, then 15 minutes, then 30 minutes, then an hour. And sometimes it just would never solve. Mamba was a reimplementation of the core solving logic in C++ to make it a lot faster. And most places have switched over to Mamba full-time. The Anaconda team that's maintaining Conda and conda-build are working on making Conda pluggable, so that we could use the Mamba solve, so that Conda can basically say, I want to use the Mamba solver as my backend. And that opens the door for other kinds of implementations that solve other problems. Boa is a similar style for conda-build. I think it's implementing more. So Mamba is predominantly using the Python APIs from Conda plus a new C++ solver. Boa is the C++. I think it's a reimplementation of most of conda-build in C++. There's also kind of a hybrid. If you do conda Mamba build, which I just put in chat. If you do conda Mamba build, that gives you the Mamba solver, but the conda build library in CLI. Yeah, perfect. Thank you, Jason. Conda-forge is extremely friendly with the Anaconda team and with the folks that build Mamba, and I think have managed to broker a little bit of some good community shifts there. Let me see if there's anything cool. I think that's it on the Q&A. I'll be around on the PyData Global Slack. Feel free to ping me there. thank you all for listening. Bye.